question 4. So, make sure you can create this diagram to represent all the forces. So we've got the normal reaction perpendicular to the plane. We're breaking down the 14 newtons into its two components. We've got the weight being 28 newtons, and we've got the friction in the opposite direction to the movement, friction being mu times r. This r and this r being the same r. So to start off, we need to resolve vertically in order to work out r, because we need that in part 2. So r, so the force is going upwards. We've got r plus this component of the 14. So that's 14 sin theta is opposite the 30. So 14 sin theta. So those are the two forces going upwards, and the only force going downwards is the 28, allowing us to work out r to be 21. Now resolving horizontally, going left, we've just got the friction, which is mu times r. R we've just worked out to be 21, so mu times 21. And our forces going to the right is just this component of the 14, so that's 14 cos theta is the adjacent side. So we got mu times 21 equals 14 cos theta, so divide through by 21 gives us mu being 0.577 as required. Now for part 2, calculate the speed of the block at the instant the 14 Newton force was removed. Okay, right, first things first, let's just work out the mass of the block, because we're going to need that in a minute. Now we're told the weight of the block is 28 newtons, so 28 is m times g, allowing us to work out the mass to be 20 over 7, remembering g is 9.8. So we're going to need that shortly. Right, so back to the question. Calculate the speed of the block at the instant the 14 Newton force was removed. Now, we're now going to use Newton second, because we have movement here, so the forces are not in equilibrium, so we need to start off by considering F equals ma. Now, in order to, the force going to our left is going to be our friction again, so we're still going to need to, provisionally, we're going to need to work out what the normal reaction is first, as that is a component of the friction. So prior to this, we need to just first of all just double check what our normal reaction is. Now this is all gone here. This is obviously perpendicular, so it doesn't count when we're resolving upwards. So r equals 28. So that first things first. So back to our F equals ma. So our net force, the only force in town when we resolve left to right, is the friction. Now because the friction is in the opposite direction to the movement, I like to consider this as like a negative force. So minus mu times r, so minus 0.577 times the resultant force of the normal reaction, the 28. So that's our net force, that's the friction going to the left. And so F equals mass times acceleration. Mass is 20 over 7, as discussed a minute ago, leaving our only unknown being A. A is our deceleration. We're decelerating at 5.66 meters per second squared. Now that we know the acceleration, we can go and work out the initial speed of the block using v squared equals u squared plus 2as. So all this work up to now has just been to work out the acceleration. So we know our final speed is 0 because the block, calculate the speed of the block at the, our final speed because it comes to rest. So our final speed, v, is 0. We're trying to work out what the initial speed is. So the u is our unknown. We know acceleration, the deceleration, so the acceleration is minus 5.66. We know this takes, the distance travelled is 3.2 meters. So substituting into v squared equals u squared plus 2as, we can work out that our initial speed was 6.02 meters per second.